Humanity has spent generations staring into the night sky, wondering whether life exists beyond Earth. Most people imagine the answer hiding around distant stars far beyond our reach, buried somewhere in galaxies we may never visit. Yet one of the strongest candidates for alien life is not outside our solar system at all. It circles Saturn every single day, frozen in darkness almost 1.5 billion kilometers away from Earth. Its name is Enceladus, a small moon that most people have never even heard of, and it may quietly hold one of the greatest discoveries in human history. At first glance, Enceladus seems completely ordinary. It is tiny compared to Earth, measuring only about 500 kilometers across. You could almost fit the entire moon inside a single large country. Its surface is wrapped in thick, bright ice that reflects sunlight so intensely that Enceladus shines like a white mirror in the darkness of space. For centuries, astronomers saw it as little more than a frozen rock orbiting Saturn among dozens of other moons. Nothing about it appeared exciting. Nothing about it suggested that it might become the center of one of the biggest scientific mysteries of our time. That view changed the moment scientists finally looked closer. Near the moon's south pole, massive cracks slash across the frozen landscape like scars stretching for hundreds of kilometers. Researchers later named them tiger stripes because of their long parallel appearance. These strange fractures were not just visible, they were warm. Compared with the rest of the moon, the temperature around them was dramatically higher, suggesting that something deep below the ice was generating heat. Then scientists witnessed something truly astonishing. Enceladus was erupting. Towering plumes of water vapor burst out of the cracks and exploded into space, carrying ice particles, salts, gases, and organic material. Some of these icy geysers blasted hundreds of kilometers above the surface before drifting outward around Saturn. This was unlike anything researchers expected from a tiny frozen moon so far from the sun. Instead of being dead and silent, Enceladus was active, alive, with motion, and constantly reshaping the space around it. The force behind this activity comes from Saturn itself. As Enceladus orbits the giant planet, powerful gravitational tides stretch and squeeze the moon over and over again. That constant flexing creates internal heat deep beneath the ice. Imagine bending a metal wire repeatedly until it becomes hot. Saturn performs the same process on an enormous cosmic scale. The pressure generates enough warmth to keep water hidden beneath the frozen crust in liquid form. For decades, Enceladus remained overlooked because nobody realized what those eruptions truly meant. Then NASA launched the Cassini spacecraft in 1997. After a 7-year journey, Cassini arrived at Saturn in 2004 and began exploring the planet, its rings, and its moons. Enceladus was not supposed to become the star of the mission. Scientists originally focused far more attention on Titan and other larger worlds. But during an early flyby, Cassini detected something impossible to ignore. The spacecraft found a thin atmosphere surrounding Enceladus along with unusual heat near the South Pole. Soon afterward, cameras captured the gigantic geysers erupting from the tiger stripes. Everything changed instantly. Scientists redirected their attention toward the little icy moon because they realized the plumes offered something extraordinary. Enceladus was throwing material from its interior directly into space, where a spacecraft could sample it without drilling through kilometers of ice. Cassini eventually flew through those plumes multiple times, collecting particles and gases from inside the eruptions. What it discovered shocked researchers around the world. The plumes contained water salts, carbon-based molecules, and molecular hydrogen. In other words, Enceladus possessed several of the essential ingredients associated with life. Suddenly, the moon transformed from an ignored speck in Saturn's system into one of the most promising places in the solar system for astrobiology. The biggest revelation came when scientists confirmed that a massive global ocean exists beneath the icy shell. This was not a tiny underground lake trapped in one location. Enceladus appears to contain an ocean stretching around the entire moon beneath layers of frozen ice. Cassini detected subtle changes in gravity that could only be explained by enormous quantities of liquid water hidden below the surface. Estimates suggest the ice crust may be around 20 kilometers thick, while the ocean beneath could extend even deeper. But liquid water alone does not guarantee life. The real question is whether the ocean contains energy and chemistry capable of supporting living organisms. Once again, Enceladus delivered incredible answers. Cassini's instruments revealed that the ocean water is salty and rich in minerals. Scientists believe the liquid sea directly touches a rocky core beneath the moon. That detail is critical because when water interacts with hot rock, powerful chemical reactions can occur. On Earth, these reactions happen near hydrothermal vents on the ocean floor, where superheated, mineral-rich water pours from cracks in the crust. Even though sunlight never reaches those depths, entire ecosystems survive there. Strange bacteria feed on chemical energy rather than sunlight, and larger organisms depend on them for survival. Evidence now suggests similar hydrothermal systems may exist on Enceladus. One of the strongest clues involves molecular hydrogen found inside the plumes. This gas can form when hot water reacts with rock in a process called serpentinization. On Earth, many microorganisms use hydrogen as an energy source. That means Enceladus may provide exactly the kind of environment where microbial life could emerge and survive for millions of years hidden beneath the ice far away from the warmth of the sun. Scientists also noticed that the plumes continuously refill Saturn's E-ring, which surrounds the planet like a halo. That discovery proved the eruptions were not temporary explosions, but an ongoing process that has likely continued for ages. Every burst from Enceladus sends ice and vapor outward into space, reminding researchers that this small moon remains active beneath its frozen exterior. What makes Enceladus truly remarkable is that scientists may not need to land there to search for life. Other ocean worlds, such as Europa, probably hide enormous seas beneath frozen crusts, but reaching them would require drilling through kilometers of solid ice. Enceladus does something completely different. It sprays material from its hidden ocean directly into space. Every eruption acts like a natural sample launcher, sending particles from the alien sea into the path of passing spacecraft. That possibility has transformed Enceladus into one of the highest priorities in planetary science. Researchers are already discussing future missions designed specifically to hunt for biological signatures inside the plumes. Advanced instruments could search for amino acids, complex organic chemistry, or even microscopic structures connected to living organisms. The technology required for such a mission already exists. The only thing missing is the spacecraft itself. Several mission concepts have been proposed, including orbiters and landers capable of repeatedly flying through the geysers while analyzing the material in extreme detail. Even if a mission launched within the next decade, the journey to Saturn would still take many years. Humanity would need patience because reaching Enceladus is not a quick expedition. Yet the reward could change our understanding of existence forever. If scientists discovered even the simplest alien microbes beneath the ice, the implications would be enormous. It would mean life did not emerge only once on a single planet under impossible circumstances. It would suggest that whenever water, energy, and chemistry combine, life may naturally appear throughout the